I would like to talk a little bit about interesting property of logical operators, logical and logical or, and it's called short circuiting. So it's just an interesting observation to make, that we said that a logical AND operator or logical OR operator, they connect together two expressions, two Boolean expressions. And the AND right here, this is we're using logical AND, and it requires that both sides have to be true for the outcome to be true as well. If at least one of them is not true, then the outcome is false, right? So it's basically, if the value is greater than from but not less than 2, the condition fails, so the value is not in range. Okay, and it's interesting thing that if this condition fails in terms of it returns false, so the value is not greater than from to be in this range, then the second part of the logical AND, its right hand side, is never evaluated. This is what we call short circuiting, because compiler decides that having this as false is enough for this not to succeed. So it just skips this part entirely. It makes it optional if this is false. But if this is true, then there is no other choice for the AND operator but to proceed forward and check the second condition to make sure that both sides are true. Similarly, logical OR that we use in the second if statement we have here, essentially what it does is if it finds out that this condition is true, then regardless of the outcome of another side, the result of OR is true, right? So OR says if this is true, or if this is true, or both are true, then the result will be okay, it will be true. And only if both are false, then the result of this is false. So if this is true, if the value is less than from, in our case, let's say we entered -1, so it's less than 5, then this part is never evaluated, because OR already knows that it's going to pass it as true outcome. So if the first condition is true, the second condition on the right hand side is never evaluated. Another example of short circuiting of logical operators. Just remember it, and so it's just a very important property of these operators. I'm sure we'll find a way to demonstrate the importance of it. It becomes really, really important when you start making function calls from these expressions. And then sometimes people are surprised that their function calls never take place. And that is just something to be aware of. Because of the short circuiting, this may or may not be evaluated at all, because it may or may not be necessary to spend time doing this part at all. All right, so there's also interesting thing, just a couple of things I'd like to use to wrap up our discussion about logical operators right here. And I'd like to navigate to this other part of our tutorials right here. There's a nice quiz that I'd like to jump to. That's the discussion about short circuiting that we just talked about. And yeah, so there's some really, really nice ideas expressed in this tutorial. And so these are the challenges. So I'll just move our code out of the way for now. as I did before. And now I'll use this to say that we have to evaluate this condition. So we just take this condition and remember, so this is some kind of if statement that wants to evaluate something like that. Okay, so we just look at the condition. Okay, so how do we, whatever, this does something, but this is our condition. So this is hard-coded condition, but you realize that this could be x greater than 0, and this could be z plus 5 equals 34 or something like that. All right, so these could be some other conditions. So let's take a look at the whole structure and see how do we approach this. So first of all, this is grouping. So this grouped together, so it will certainly be evaluated before anything else, because this is the most nested level of parentheses in this entire structure. So this is definitely evaluated first. So I just kind of copy and paste this without paying attention to the syntax. So this definitely should become true, because that's exactly when logical AND becomes true, when both sides are true. So this becomes true, right? And then, of course, true or false, right? Oh, by the way, and there is something else to mention here, that logical OR will short-circuit this. So this really, just like this, really never evaluated, because logical OR already sees that, oh, this is already true. So the whole outcome of this is, of course, is true. So this just becomes a true outcome right here. Okay, so this is equivalent to the final result like this, if we kept all of our parentheses like this. So this is the progression. Check this because it's inside the parentheses and finds out that both sides are true, so it's true. OR operator looks at this result and says, I don't even care what this is, because this is true, and therefore I give you a true outcome. Okay, so this is, you can of course check the solution and see what I do here is what the solution shows you. Let's take a look at this, another example. So we'll just kind of restart this little talk like this. I'll just copy and paste. All right, so once again, now we have false and true, and once again everything is parenthesized. So we must use this as a first step into finding out how this condition resolves itself. And we see the AND operator and we see false. So of course this is sort of like never evaluated or never even looked at, because this is false. And because of this, so I should probably just duplicate it. So here I'll just keep it true, right? And here duplicate it, and one more time duplicate it, that this is a false outcome, right? So we pay attention to short-circuiting and what happens to the outcomes of Boolean sub-expressions here. And so then, of course, we have false, but we have an OR operator, and OR operator wants to say, well, maybe this is true. And of course it is true, so this is not short-circuited, and the outcome is also true. Right, so the final result is that it's all true, and I'll just put it like below the OR statement right here, and that's the outcome. This is how it gets resolved to true. And then the next statement, show solution. Sorry, this right here. I'll leave it for you to evaluate. Let's take a look at this. Another example, just kind of rewind back to where I was, right, with my trying to think like compiler. By the way, oftentimes you have to think like compiler. I like to add spaces in my style, it just keeps me a little bit more focused on the entire expression. Okay, so it's very similar to what we did, but this time we have to, of course, evaluate the sub-expressions such as 5 greater than 6. No, this is false, right? Then there is an OR statement, I mean the OR operator, so of course it says, okay, you are false, but how about this side? 4 greater than 3 is true. Okay, so we've got that. Of course, now we can progress to a little bit more and say, okay, then of course this is true, like this, because an OR operator wants just one side to be true, and this is okay. 7 greater than else is false. So we're gonna have to say this is a false thing right here. And then and of course it was evaluated because AND wants both sides to be true. So this one was true, but how about this one? It had to compare 7 and 8 and say, no, it's false. So then, of course, the final outcome of this should be a false, because AND tells us, no, I don't work like this. It's not true. Okay, so these are, like, my best attempts to make an alignment and show you the progression of all of these checks. So you have to keep an eye on every part, but the simple thing is that whenever something is parenthesized, you want to look inside the parentheses, and it happens before anything outside the parentheses, right? And let's just check the solution to make sure. Yes, so it's false. Okay, good. So anyways, just check these quizzes. They're very nice, nicely put together, so they definitely should make you think about how you would approach a certain condition when you put it together, or when you're trying to understand an existing condition, and make sure that you think the same exact way as your compiler would approach solving this expression for you. Okay.